3.3 rules for differentiation. So today we're going to start derivatives using the shortcut, or shortcuts, because there's actually a lot of them. But then we don't have to do the really long definition of a derivative using the limit as h approaches 0 and all that stuff. Okay, so example 1, we're using the constant rule. And the constant rule is whenever you're finding the derivative of a function that is just a number, right? Because that's what the word constant means, just a number, no variables involved, no x's, no y's. The derivative is always going to be 0. So y prime will equal 0. And the reason for that is because if I were to graph y equals 0, so let me graph y equals 7. So let's say this is 7. Okay, so then my graph would be this horizontal line. That is y equals 7. Remember, derivative is the slope. That's not something you're allowed to forget. Derivative is slope. So basically, what I'm asking you to do is tell me the slope of this line. And if you look at it, the slope of that line is 0 because it's horizontal. And all horizontal lines have a slope of 0. So anytime that I have a function that is just a number, the derivative is always going to be 0. So b, the derivative of this function, is 0 because that is a horizontal line at y equals 0. For c, the derivative of this function, s prime of t, this is notation, right, for derivatives, s prime of t is going to be 0. For d, the derivative, well, this one's a little different. They're telling me, yo, k is a constant. Pi is also a constant. It's a really long decimal that never terminates, but it's still a constant. So there aren't any x's here. There aren't any variables. So the derivative, and this time I'll call it dy dx, is 0. Notice I use proper notation for all of them. When you have y, you can use y prime, or you can use dy dx. Okay, so y prime or dy dx. For f, a function that is f of x, f prime of x works. And for c, I had a function called s of t, s prime of t. You have to write it this way. Okay, first basic rule of differentiation is the power rule. And the power rule looks like this. If I derive, or if I have to derive something that, or a function that looks like this, x to the nth power. Okay, n is an exponent in this example here, or in this formula. Whenever I have to derive anything that looks like that, x to the nth power, the rule goes like this, or the shortcut. You take n, bring it to the front to multiply by the x to the n, but then you subtract 1 power from the exponent. Whatever it was. If it was 5, you subtract 1, it equals 4. If it was 2, you subtract 1, it equals 1. If it was 1, you subtract 1, and it turns into a 0. And we should all know, if you have a degree or exponent of 0, that your answer is always 1. That is how you do the derivative using the power rule. That's the most basic derivative that you'll do. Okay, so now on to example 2, using the power rule. So I have f of x equals x cubed. Okay, so remember, what I'm going to do is, I want to derive this. So I'm going to bring n to the front, and n is the exponent, times x to the nth power. And I'm going to subtract 1. So my derivative, f prime of x, is going to equal. So I'm going to bring my 3 to the front. My 3 is going to come to the front, so it's 3 times My original function was x cubed. Then I got to subtract one exponent from it. So you bring the exponent to the front first to multiply with the function, and then you subtract one exponent. So my final answer is 3x squared. That is the derivative. All right, moving on to b. Here I have a cubed root. Please rewrite this. And when I say rewrite, I mean instead of using cubed root in the form that it is right now, you're going to change that to an exponent. This is actually x to the 1/3 power. Cubed root is 1/3. Square root is 1/2, right? So now I'm going to derive this because it is written in a friendlier way. So g prime of x, I bring 1/3 up to the front, multiply by x to the 1/3, but then I have to remind myself, oh, I have to subtract 1. Now I have 1/3 minus 1. So you have to actually figure out, okay, what is 1/3 take away a whole? So my answer is 1/3 times x to the negative 2/3 power. And that's my answer for the derivative. Okay, C and D. So let's see. Rewrite this. It helps. I'm going to rewrite this as negative 3/2 times x. Now here, x has an exponent, but it's a 1. And I also have a coefficient. I have a number being multiplied by the x. But the rule still applies. So I'm going to, I'll do dy dx, or y prime, whichever you prefer. So let's see. I'm going to bring my exponent to the front. So what is 1 times negative 3/2? Oh, it's negative 3/2. And then x, and then I have to subtract 1, right? Subtract 1. So what is 1 minus 1? Oh, it's 0. So here's what I was talking about earlier. What is x to the 0 power? What's anything to the 0 power? The answer is always 1. So really what I have here is negative 3/2 times 1. But I don't have to write the times 1. So now I just have negative 3/2. My derivative is negative 3/2. Every time you have a lonely x, just one little x, your derivative is actually the number in front of it. Negative 3/2, the coefficient. D, similar but not exactly the same. I'm going to rewrite it as well. You don't have to always do this. Eventually, I'd hope you could do this without having to rewrite. But I separated the 4/5 from the t squared. So I'm going to find the derivative. So f prime of t, notice how here my variable is t, not x. That's okay. I'm going to bring the 2 up to the front. My exponent comes up to the front. So I have 2 times 4/5. T originally was squared, but then I'm supposed to subtract 1, right? So now I have, let's see, what is 2 times 4? That's 8/5. And then the 2 minus 1, that just leaves one lonely t. And that is my derivative. F prime of t is 8/5 t. Or if you like, you can write 8t/5. Same thing. No biggie. Example 3, using the sum and difference rule. Okay, so all the other examples, I only had one term. And we took the derivative of that one term. For example, example 2, a was x cubed. That's one term. Well, sum and difference is they start adding and subtracting terms. So they actually make these longer equations or expressions or functions, whatever you want to call them. But the rule is the same. It doesn't matter how long it is. You're just going to take the derivative of each term. That's it. So the first one, a f prime of x. Okay, so bring the 3 to the front. So I have 3 times 2, and then x, and my 3, I'm supposed to subtract 1, and I end up with 2. Minus, let's see, 4x. Remember, this x only has an exponent of 1, so when I bring that to the front, the 4 is going to stay the same, but the x to the 1 power is going to change to x to the 0 power, because I'm going to subtract 1. And so basically the x just goes away. So I'm left with 4. And then the last term, plus 5. 5 is a constant, and the derivative of a constant is always 0, because that is basically a graph of a horizontal line, and the slope of a horizontal line is 0. So what I really have, once I simplify this, 3 times 2 is 6x squared minus 4. Obviously, you won't have to do all of this work once you know how to do this. You'll just do it automatically. I'm doing it because this is the first time most of you have seen this. All right, B. So same thing. It might help, or it might be helpful for you to rewrite this. So let's see. I rewrite it as 1 or negative 1/2 x to the 4th plus 3x cubed minus 2x. So now let's see what I have. So the derivative, so g prime of x. All right, bring the 4 to the front. Okay, what is 4 times a negative half? That's negative 2. And then x, and then my 4, I have to subtract 1, and I end up with 3. Okay, plus, bring my 3 to the front, multiply it with the 3 that's already there. I have 9, and then x, and then my original exponent that was a 3 or a cube, I subtract 1, and I end up with a square. Next, minus 2x. Remember, this has an exponent of 1, so basically the easiest way to say the rule is just that the x disappears, goes away, because you're subtracting a degree from it, and you're just left with the negative 2. And that is the derivative of b. All right, example 4, the second derivative. So this is actually a higher order derivative. And higher order just means if you do the derivative more than one time, it's a higher order. Notice the notation, please. Find d2y over dx2. Okay, this is how you would determine the second derivative. And the second derivative is just taking the first derivative, which is the one we've been working on for all these examples. And then once you have that new function, which is your derivative, you're going to go ahead and find the derivative of that. And that is your second derivative. So let's see. Here I have a function, y equals x to the 5th minus 3x cubed plus 7. Let me find the derivative, y prime. I'll call it y prime. Well, you know what? Never mind. I'll call it dy dx, just to keep all the notation the same. So dy dx. Okay, so bring the 5 to the front, and x to the 4th power. Minus, all right, bring that 3 to the front, multiply with the 3 that's already there, get 9x squared. And then the 7 is just a constant. There aren't any variables, so it disappears. It goes away. It becomes 0 because the slope of a constant is the slope of a horizontal line, which is 0. So here's my derivative. This is my first derivative. They want me to find the second derivative. So in order to find the second derivative, I have to do this again. So I use the notation d2y over dx2. This is the second derivative. So I'm just going to derive the derivative. I'm going to derive again. So bring the 4 to the front, multiply it with the 5, so that's 20. X, subtract 1, that leaves me with a 3. Minus, bring the 2 to the front, multiply it with the 9, it's 18. X, and then I subtract 1. So 2 minus 1 is 1. I don't have to actually write the 1. And here is my second derivative. This is a higher order derivative. Most of the time, if you have to do a higher order derivative, it will be the second one. 90% of the time. Sometimes they'll ask you to do a third or a fourth or a fifth derivative. Okay, product rule. So this rule for deriving is a shortcut for when you have two things being multiplied. Now this is what it looks like. If I derive a function that is one function, we're going to call it u, being multiplied by another function, we're going to call it v, then the derivative is as follows. You take u, the function u, whatever that is, and you multiply it by the derivative of v. We're going to call it v prime. Then you add the function v times the derivative of u. This is the product rule. This is a shortcut to finding the derivative when there are two functions being multiplied. Now, I'm going to share the verbiage for this product rule, or the words of how I would say this. So this is how I would say this. I would say the first. When I say first, I mean the first function. In this case, it's u. So the first times the derivative of the second. And when I say second, I mean the second function, which is v, plus the second, so that's the second function v, times the derivative of the first. And I want you to know what this sounds like, because I'm going to say it often, and I want you to know what the heck I'm talking about. So basically, those are the words that go along with the product rule. This is the first, this is the second. So the first times the derivative of the second plus the second times the derivative of the first. Okay, so find, example 5 says find f prime of x if f of x equals the quantity x squared plus 1 times the quantity x cubed plus 3. Now notice, these are two things being multiplied, two binomials or two expressions, whatever you want to call them. So the first one, the one on the left, we're going to call that u. And the one on the right, we're going to call that v. Now to start off, and maybe even after that, the whole year long, I suggest taking u and taking v and figuring out what their derivatives are. So u is x squared plus 1. And you have enough space on your paper, you can do this all on the left side and then do all your work on the right. So now find the derivative of u. Find u prime using our basic rules. So bring the 2 to the front, subtract 1 exponent, so my derivative is 2x. Okay, so now do v. So v is x cubed plus 3. Okay, so find v prime. So bring the 3 to the front, I have x, and then subtract 1. So that's 3x squared plus 3, but 3 is a constant, Just like 1 was a constant, that's why I didn't do anything with it. It becomes 0. So now I have my pieces. So then the derivative, f prime of x, that's what I'm looking for, is going to follow the product rule, which is u. So u times v prime, right? The derivative of the first times the derivative of the, or sorry, the first times the derivative of the second. That's the first half. Plus v times u prime. So the first times the derivative of the second plus the second function times the derivative of the first. So that right there, ladies and gentlemen, is my derivative. Mostly you will have to simplify this. You're actually going to have to multiply out and distribute. Now that shouldn't be the hard part because that's like old math stuff that you should know, right? From algebra. So I suggest you try to see if you can, if you distribute properly. I'm going to write the answers, or, you know, I'm going to work it out. So I multiplied stuff out, and this is what I got so far. And then that can be simplified because I have 3x to the fourth plus 2x to the fourth, so that's 5x to the fourth, and then plus 3x squared plus 6. And this is the most simplified I can get. Now sometimes they will tell you, oh, find the derivative of f when x equals 2. So then you can go ahead and plug in the 2. And you don't actually have to simplify anything because you could just plug in the 2 whenever. But for right now, this is going to be my answer. This is simplified as long as I did my math correctly. So check to see if you can get the same answer. All right, example 6. Same thing. Find the derivative of h of x. Here I have two things being multiplied. So I'm going to call this u, and I'm going to call this v. And I'm going to set it up for myself because I want to make sure that I plug in the stuff correctly. So u is 3x minus 2x squared. So u prime, or the derivative of that, is 3 minus 4x. Now v, see v is the second function, 5 plus 4x. V prime, let's see, 5 is a constant, so it becomes 0. And then 4x, basically the x just goes away, and I'm left with 4. So now I'm going to find my derivative. So h prime of x. And this is the product rule. So it'll be u times v prime plus v times u prime. Okay? U times v prime plus v times u prime. That's what I'm doing right now. So u, 3x minus 2x squared times v prime, which is 4, plus, so we're about like this right now, plus 3, which is 5 plus 4x times u prime, which is 3 minus 4x. And this, ladies and gentlemen, is my derivative. But yes, you do normally have to simplify this. I'm just trying to show you how to do the derivative. I'm not here to show you the algebra behind it. So once again, I'm going to distribute and write it down for you. Check your work, please. Okay, so The green is what I got from the left side when I multiplied it out, and the purple is what I got from the right side when I multiplied it out. So now you can simplify. And there's my last answer, my final answer. That is completely simplified, and that would be the derivative, like the answer that I would submit. Next on the agenda is the quotient rule. Now, we just did the product rule. Product means to multiply. Quotient is dividing. So this time, when I am trying to derive a function that is really one function being divided by another, the derivative is as follows. V times u prime minus u times v prime. And that is divided by v squared. Now I'm going to put this in words. I'm going to write it down, and then I'll say it out loud. All right, so don't make fun of me, but low d high minus high d low over low times low. This one's a little more like catchy. It's helpful to help you memorize it. You might be like, this lady's on crack, but later on if I hear you singing this, I'm going to laugh in your face. It's low d high minus high d low over low times low. Okay, so low signifies the function on the denominator part of the fraction. The high means the numerator. And then the d signifies derivative. So low times the derivative of the top one minus the top one times the derivative of the bottom one. And over, as in a fraction, divided by the bottom one times the bottom one. And that's another way of saying, the v squared. Okay, so example 7, differentiate f of x equals x squared minus 1 over x squared plus 1. So here I have a function being divided by another function. So we're going to call this u on top and v on the bottom. So just like the product rule, I would much rather you take the time to figure out, okay, what is u? U is the top, which is x squared minus 1. U prime is going to be the derivative of that, which is 2x. So now, all right, v is the bottom, the low part, x squared plus 1. V prime is the derivative of that, which is also just 2x. So now I'm going to find my derivative. F prime of x equals. Okay, so low, that's the bottom part, 2x, or sorry, x squared plus 1. So low, d high, so the derivative of the top, which is 2x, minus so low d high, that's what I've done, minus high, that's the top, and then times the derivative of the bottom, which is also 2x. So I have low d high minus high d low. And then over low times low. So the low part is the v. So you take the v and you multiply it times, again, itself, so it's just squared. And then this is the derivative. Yes, you have to simplify it. So sorry about your luck. They expect you to know how to do algebra. Go figure. So I'm going to do that off screen. Okay, so I distributed, and that's what I got. I could simplify this a little because there are some things that cancel out. So I get actually 4x over x squared plus 1 squared. And that's perfectly fine. Okay, last example before the try it. Sometimes, not always, when you have a function that is as complicated as this example, it might be better for you to just distribute. this function, or this, yeah, this function, I derived it using the product rule because these two things are being multiplied. The numerator, there's two functions there. And then I used the quotient rule. And it seemed a little bit longer than if I had just gone ahead and distributed these out first. So sometimes it's easier to distribute. In your homework, I suggest you distribute. So I'm going to go ahead and do that, not on screen. Okay, so here's my first round of distributing. I did check my work, so I hope I didn't mess up. And this can be simplified. So, okay, so here it is simplified. This is my function now. It's a little long, but no big deal. This is going to be my u, and this is going to be my v. I'm going to now find the derivative using the quotient rule. I have not found any derivative yet. All I did was distribute. Okay, so I moved it around so I can have more space. All right, so I just did low d high. Now I'm going to do minus high, which is really, really long. So this is high. And now I do d low, which is the derivative of the bottom, over low times low. So the bottom part, the denominator squared. So this is the derivative. I don't want to torture you, so I'm going to leave it like this. Okay? This is a really long equation. All right, finally the try it. I suggest you pause it and you try this on your own. Pause it now. Okay, so here's the derivative. The blue and the purple, obviously you can tell where I got that stuff from. I did simplify it. I urge you practice your algebra skills because you need to know how to do this. I'm showing all my work. Well, most of my work, sorry. Not a lot, right? Let's see if you can get the same answer. Okay, so here's the rest of the work. And that's the answer right here. Okay? Do your homework.
With me.